So, welcome to the next part of the tutorial. As I already mentioned the last time, I'm gonna show now how to do the rotation around the x-axis. So far, we can now rotate to the left and to the right, which is similar to a rotation around the y-axis. And what I would like to do now is looking up and down, which is a rotation, in this position kinda around the x-axis. But this is a little bit more complicated because once we turn to the left, or let's say totally to the left, it would be actually a rotation around the z-axis. And in the middle, it would be a rotation around a combination of both axes. So, as you can see, it's a little bit more complicated than the simple left and right looking. Plus, we need to consider something else. We don't want to look turn around so the whole terrain could be actually upside down. We want to keep the terrain always in that position, so maximum looking down 90 degree and looking up 90 degree is a second restriction. So yeah, let's get straight into coding. The first thing I would need is now similar to the rotation around the y-axis, float. Let's call it rot x. Actually, it's rot x, a rotation variable for rotation around the x and or z axis. And we set this initially to 0. And we also will need such a temporary variable to do the same trick as with the y rotation, but we're gonna come to this soon enough. So yeah, that's the first step. The second part is now, while we were rotating around the y-axis, we kind of influenced our look at vector on the x-coordinates, simply the math sinus of rotation y over here. So, and the z is the cosinus of the rotation angle. Yeah, let's call this the rotation y angle. And now when we want to look up and down, we kind of need to change something with our y-axis. The look at on the y-axis. It's already initially set to -1, which means the camera position and -1 this should be. So the x and z is somewhere in front of us, and it's a little bit down. If we set this to 0, then we would look straight forward. And that's how we gonna start it. We set the rotation xy here to 0, so we forget about the -1 and look straight forward. So float, and it's math dot pi, math dot sinus of, and now we have the rotation xz plus our position. So, and rotation xz, if we use the sinus or the cosinus, here it would not matter. We have to kind of choose one option. Both would work. We just would need to change the initial angle to work properly. But a sinus is pretty okay here. So, and it is a little bit easier, I realized for myself when I'm trying things out, to first do some basic things, always setting them on a key, like a rotation or a looking up I put on a key and separately looking down on a key. And I don't try out initially to put everything on the mouse, which just complicates the whole thing, but separate these two operations, and that's why I set two keys first. Later on we will see we actually don't need them, but it's not a bad thing to actually have it. And I use simply the up and the mouse and the up and the down keyboard key. So keys up and a break, so he stops whining, and this a second time, but for down. I hope this video won't take too long, but it's a little bit of more information than in the previous video. So okay, what are we gonna do initially? Or we just add here the whole thing with the turn speed plus equals our turn speed. That's for now everything. We're gonna add here something later, but I'm gonna explain what. So K is up and K is down should be set, and I should be able to look down and up already. Yep, this looks very great. But yep, it seems to work. Up, down. Let's go a little bit forward and up and down. So, but there are a couple of problems which we gonna see. The first thing for now is that we cannot look further down than approx 45 degrees. I keep clicking downwards, and as soon as I reach the 45 degrees, I will stop, and although I keep clicking downwards, I will now go up. I will go up until 45 degrees looking into the sky, and it will happen again that I change the direction and go down. So why is that? It's simply because I'm going up and down according to the sinus, and this is somehow explained over here. Try to draw it. I have my camera position over here, and in front of it, on now set on 0, I have my look at Y value. Here that line represents the terrain, and that's the z-axis initially. So the sinus simply makes me going up and going down and going up and down. So we cannot go further down than 45 degrees. If we would not use the sinus here and just say let's count up as much as we want, at one point we would be maybe at 2, and we would be able to look further and further up and steeper, but our increase of the angle will slow down a lot, and we will never be able to reach actually 90 degrees because simply we are moving along this. So the solution to actually move, look downwards totally 90 degrees while still using the sinus over here is simply by moving the camera set, because we're here on the set axis, while we're moving up or down towards the camera. So once we are here at -1, the set should be here totally at 0, that we end up over here, and then the camera would look down. Yeah, let's do that and see if it works. How to do that? It's not that hard. We simply have to, here where we calculate the camera look at set, we need to now, according to our rotation xz variable, I need to move it now closer towards the camera. And the camera is somewhere in between 1. So, which means we need to bring the set a little bit closer, and we do it by adding the float of the math sinus of the rotation xz. So let's try if it works. Let's go a bit further. Whoa, 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 what happened here? Okay. Yep, it seems to work. Let's go down. No, still not. I'm looking back up. Okay, what did I do wrong? I go... Has the sinus of xz. Why do I have a... Of course, a plus. Need a plus over here, sorry. Ah, now. Okay, let's move a bit forward and let's go down. And now I'm able to go totally into bird's perspective. 90 degree. But a huge problem appears. It only works while I'm looking into the direction of the z-axis and while the x-axis is left and right. As soon as I rotate a little bit to the left and would now try to look down, it goes a little bit directional. Let's go back up. Let's turn a bit more. Oh yeah, now the turning is already there. And now let's go down. And he does crazy things. And this is simply because as soon as we change the rotation, we can't just consider the z-axis, but actually have to also consider the x-axis. And what we have to do is simply adding here the very same. So once this now would work as this would work perfectly if we look straight forward into the x-axis, then this must be 0, as into the direction of the z-axis. If we look here in the direction of the z-axis, then this should be added and this should be 0. And as soon as we would be 90 degrees to the left or to the right, then we are looking along the x-axis. Then we should add this to our camera position, so the look at goes below the camera position properly, and set this to 0. And therefore we simply add this whole thing with something between 0 and 1, which is of course our rotation y, the sinus of that. Because depending on how far we turned around on our y-axis, I can get a value between 0 and 1 for that. I just need to multiply this here with 0 or 1, or in our case with the sinus over here, and down here the cosinus. Cosinus. And yeah, now it should work. So we created now our xz axis somehow with this term to have proper xz calculation. and the looking up and looking down is still done over here. And let's go and see and check it. Let's look down. It works. Let's go to the turn to the left, going down, turn a bit further, going down. So it works now for all rotation angles, and I can totally look into the bird's perspective 90 degrees down. But one thing is still a problem. This as soon as I keep going down at 90 degrees here, it will turn around, and although I keep looking downwards, it will go back upwards. Simply because we go down until this point, plus we move on our axis now over here, and once we are over here, we will go back up and we'll go up here, and that's where we loop around, so to say. This is what we want to avoid, and therefore we simply don't allow going any further anymore. So once we are going up, I'm gonna ask how big is the DirectX set already, and if this is smaller than 90 degree to the top, 90 degree in radians is math pi divided by 2. So once we're looking, our rotation xz is smaller than 90 degree, then only then increase the turn speed, which means it will stop, it will lock in, and it's not possible to get any further up. And yeah, theoretically you can just copy this. I just like it more using brackets. Simply it can always be that I have to add something. So the same applies down here, simply with while rotation xz is bigger than minus 90 degree. So from minus 90 degree totally looking down to plus 90 degree, I am now allowed to turn around, and therefore this is exactly this loop which is always changing. So 180 degree of looking around I have available, and yeah, that's it. I'm not gonna start the program now. I'm assuming and hoping that it's running properly. What we want to do now is the last part, is to add this whole thing also to our mouse move, so that I can grab the terrain similar to looking left and looking right. I would like to look up and down by going up and down with my mouse. So yeah, let's check this rotation quickly. So it should not be able... I'm not totally stuck at 90 degree. Whatever I press, it's not working, and as soon as I go back up, it's working until 90 degree. Yeah, we won't see anything, but yeah, it's working as planned. Let's go to our mouse moving. We can use the same thing as previously. The mouse middle button is already set, and as soon as the mouse middle is being pressed, we're gonna do something with our rotation xz. Now what we're gonna do kind of similar thing as over here. We simply use our E now from the y-axis, the up and down location of our mouse is saved on the y-axis, and this one we float it. Actually not. E dot y times the turn speed. But I discovered that this is a bit too fast, so I divide here the turn speed by 4. For the key it's working, plus for the left and right the turn speed is properly set, but for up and down moving the turn speed is a little bit too fast, so I divide it simply here by 4. Because the turn speed is a float, I don't have to cast it here. And we need to do the same trick with the temporary Y, like the temporary Y, that wherever we click on the screen, it always evens it out and will not hop around and calculate the wrong position. So therefore we defined at the beginning already our temporary x, y, and we do here the same trick. So temporary x, y, why don't you want me? Because we didn't set it, or no? How did we call it? Xset, of course. Silly. Not xy. Xset, temporary xset. And down here, we did it earlier as well. We need to set the temporary somehow. Come on. And minus. So will this work now? Let's try. Let's go forward, middle mouse button pressed. Aha. You don't see it, but if I move upwards, I'm going down. So it's set in the wrong direction. I don't like that. So we have to change it. DirectX is minus. And here plus. So now I can grab the terrain at any point, like, or click somewhere on the window and simply go down, and I can keep it pushed down and simply move around our terrain. I click now straight forward and I go around. I can look totally down to 90 degree, move around. The only thing which we did forget yet for the mouse is once I go with the mouse moving totally down until I reach 90 degree bird's perspective, and I would move my mouse still a little further, we have the same error as with the keys. The further I move now down, the further I look up, and I'm having now the same problem. So how to fix that? Over here it was easy. We did it with that mathpy, but here the whole calculation was split up. Therefore, this is not gonna work that easily down here, because we have to ask it in one sentence. If, what is it? Here it's not split up, here it's doing both movements, down and up, so we have to do it in one if. but this will give us a little problem. The problem is that the rotation XZ is only calculated in between, and as soon as we reach one of these two borders, so to say, the camera will be stuck. I scroll up a bit, and now let's move down, and let's move down until 90 degree. So I'm 90 degree down. I still can look to the left and to the right, but I'm not able to get up anymore. I am totally stuck over here. Simply because once one of these borders is being reached, rotation XZ has this value that it's not going in there, and it's not calculating itself out of this problematic position anymore. So we are stuck. Therefore, to solve this over here, we need a small and short-term temporary variable, which actually does our calculation and keeps doing our calculation even if we reach this border down here, but only once it's in between the two borders, only then it will actually affect the rotation XZ value. So it will keep, even if rotation XZ is has reached the border of 90 degree looking downwards or 90 degree looking upwards, it will not do anything in here anymore, but the temporary variable keeps calculating properly. So as soon as we go back up, it allows it instantly, but of course we need to ask here not for rotation XZ, because this would change nothing. We still will be stuck. Yep, we are stuck. We cannot get up anymore. We have to ask the temporary. So the temporary will be calculated, but only once the temporary variable is in between this border, it actually gives the value to the rotation XZ. So, and now it should work. Took long enough. I go totally down. I can't go any further down. I'm sorry, I'm moving a little bit to the left and right with the mouse, although I just wanted to show the down moving. So I can't go any further, but as soon as I look back up, that's it. And the only problem would be maybe if I click here now on the locked position, would go down and wouldn't release. I cannot go back up until I reach the point of the calculation. Now here it works. And therefore, so what's working now? Actually everything, all of my mouse control. I can now freely move in our terrain. I can do whatever I want. One last thing could be done if it's being wished, and this would be once we look down and press forward, we could now decide if we want to stay on the same level like we do now, or if we want to go actually into the direction of the way we are looking. This is a preference. For me, it's very okay to leave it the way it is, and gives me a little bit more control over the orientation of where I'm actually not getting lost. So yeah, this is actually everything about the rotation around with a keyboard, with the mouse, walking forward, walking backwards. Everything is now covered, even going up. However we set it, we used now the mouse wheel for doing some stuff. We used now the mouse moving, the mouse clicking. plus our keyboard. So a lot of things are now covered and can be changed however we feel like. So yeah, just remember the y-axis is requires a little bit of sinus and cosinus usage, and as soon as we would look up and down, we have to think about the two things. First of all, that we need to rotate not around the x or the z-axis, but a combination out of both, which we set up on top. Plus, we need to kind of lock the looking down. Plus, there would be another way to look down by simply decreasing it constantly without a sinus or a cosinus. So we would be even able to go further than 90 degree. But if any of this is considered or tried out as a calculation, then it should be definitely blocked, because otherwise, if we would go further down and wouldn't allow it, or wouldn't stop it, then we would see at one point the whole terrain, the whole world upside down, because we just see it from the other way. And so up and down moving should be really restricted to maximum 90 degree down and 90 degree up. Yeah, that's it for this tutorial. What am I planning for the next tutorial? The next tutorial will be covering how to use some basic Windows Forms structures in our terrain. I would like to use a strip menu over here, because we are using the Windows Forms. Why not using also the stuff provided by Windows in combination with our DirectX? So I'm gonna implement a simple menu over here, and once we have this menu, we can then set up different options, and later I would like to set one options, for instance, loading a high map into our terrain and having already a basic menu. There's a little bit to think about, to know how this works, and yeah, thank you for watching. I think this was a little bit of a longer tutorial, but it was a bit of a more complicated one. Yep, please subscribe. This was Nex. See you.